In this video, we're going to talk about another conic section, which is the ellipse. So we define an ellipse as a locus of points on the plane such that the sum of the distances of a point P to two fixed points called foci is constant. So we can see here on this GIF, the moving point there is our point P. And the points here, the two fixed points, are our foci. This is one focus. This is another focus. So as you can see, the red lines there, the red segments, are the distances from the point to the two points. And for it to have a shape of an ellipse, it's the sum. The sum of these 2 points must always be constant. Now, take note that in the general form of a conic section, the general form of the equation of a conic section, ax squared plus cy squared plus dx plus ey plus f equals 0, the graph is an ellipse that is not a circle if A is not equal to C, but they are like sign. Either they are both positive or both negative. So most of the time it will be both positive. If they're both negative, they usually divide everything by -1. Now, to obtain the simplest equation for an ellipse, we place the foci on the x-axis at f sub 1 rather, which is at -c0. Here you go. And f sub 2, which is at c0. So these are the coordinates of our two foci. So that the origin is halfway between them, and hence we call that the center, which is the midpoint of our two foci. In the event that the foci of the ellipse coincides with the center, then the ellipse is a circle. That's why in the parts of a circle, we don't have any foci. But once the foci will move up or not coincide with this, so it's not anymore a circle, but an ellipse. It's not a circle. So, based from the definition that we had a while ago, let's paste this here, we are told that the distance of any point P from f sub 1 plus the distance of that same point P on the ellipse from f sub 2 will always be that constant. Let's have the constant m. So the question is, what is that constant m that we need when we have to derive the simplest equation for an ellipse? Now, let's take this point here. Let's name this point P sub 1 with coordinates A0. P sub 1 with coordinates A0. So V sub 1 is on the ellipse, so it can also be P. P is any point on the ellipse, and V sub 1 is a point on the ellipse, so P can also be V. So therefore, I can say that V sub 1 F sub 1 plus V sub 1 F sub 2 is the same as this constant M. Why did we choose V sub 1? Because it's horizontally aligned to our two foci. It's easier to compute that distance. So if we're going to ask what is the distance between V sub 1 and F sub 1, all we need to do is subtract the abscissas. We're going to get A minus -c. If I'm going to do the same to find the distance between V sub 1 and F sub 2, I'm going to subtract again the abscissas. That's A minus c. Let's simplify things by removing the double negative and removing the absolute value since we're just concerned about distance. So A minus -c becomes A plus c. This becomes just A minus c. Combining like terms, c minus c becomes 0, A plus A becomes 2A. Therefore, that constant, that sum that is a constant, will be 2A. And that's what we are going to use now to derive the equation of the ellipse from here. Since M is equal to 2A by substitution, we're now going to have any point P, the distance of any point P from F sub 1 plus the distance of that same point P to F sub 2 would be 2A. So if we let P, say for example here, with coordinates x, y, so the distance between P and F sub 1, from P to F sub 1, plus the distance between P to F sub 2 would always be the constant 2A. So how do we now derive an equation from that? So the distance now between P to F sub 1, it's not anymore horizontal, nor it's vertical. So we use the distance formula. So therefore, I'm now going to have the difference of the abscissas, that's x minus negative c squared, plus the difference of the ordinates, y minus 0 squared, plus the distance now from P to F sub 2. So the difference of the abscissas, that's now x minus c squared plus y minus 0 squared is equal to 2a, following our formulas of our distance formula. Let's simplify things, so therefore this would become x plus c squared plus y minus c squared plus, this becomes the square root of x minus c squared. Oh, sorry, that's not y minus c, but just y squared plus y squared. This becomes plus y squared is equal to 2a. So, we would need to simplify this by removing the square roots, and it is advisable to just leave one radical on one side, because if we leave the two radicals there, it would be a bit difficult to work with because it gets a bit more complicated of a radical. So we should transpose. Let's transpose this one here. I'm going to have the square root of x plus c squared plus y squared is now equal to 2 minus the square root of x minus c squared plus y squared. Now we can then get the square root from both sides. Let me just fix the view of our board. There we go. So now from here, we are now going to have this gets cancelled. I'm going to have x plus c squared plus y squared is equal to, this is a binomial. This one here, this is a binomial, so we would have to square a binomial. We get the square of this term, that's 4a squared. We then get the product of this and this term, then multiply it again to 2. So I'm going to have minus 4a, the square root of x minus c squared plus y squared, plus the square of this, which is x minus c squared plus y squared. So let's bring the computation here. We expand our squared binomials here, so this will become x squared plus 2cx plus c squared plus y squared is equal to 4a squared minus 4a. I'm not going to expand the one inside the radicals, x minus c squared plus y squared, but I'm going to expand this. So this becomes plus x squared minus 2cx plus c squared plus y squared. In algebra, if we have same terms with the same sign, so there are same terms on opposite side of the equation, we can cancel them because once we transpose one to the other side, the difference will be 0. So we can cancel x squared, we can cancel c squared, we can cancel y squared. Now, since we only have one radical left, let's leave it all alone there and transpose those that are not radicals, such as negative 2cx and 4a squared, to the left side. So therefore, you have 2cx, this negative becomes positive. So 2cx plus 2cx, we're going to have 4cx. Transposing this, I'm going to have minus 4a squared is equal to negative 4a square root of x minus c squared plus y squared. So we wrote that a bit small, but anyway. So from here, we have a common factor of 4, so we divide everything by 4. So therefore, I'm going to have cx minus a squared is equal to a square root of x minus c squared plus y squared. So this is now what we square to remove that square root symbol, because we don't have a square root symbol in our general form. So therefore, squaring this binomial, I'm going to have c squared x squared minus 2a squared cx plus a to the 4th, square root of this, then is equal to this, this is supposed to be negative a. So the square of negative a is still a squared, then I'm going to have x minus c squared plus y squared. So before I distribute a squared here, let's expand this. So the left side just remains the same, plus a raised to 4 is equal to a squared multiplied by expanding this becomes x squared minus 2cx plus c squared plus y squared. Let's now distribute a squared. So I'm going to have still c squared x squared minus 2a squared cx plus a to the fourth on the left side. On the right side, I'm now going to have a squared x squared minus 2a squared cx rather plus a squared c squared plus a squared y squared. Based from this, what we can cancel is negative 2a squared cx. Now, let's combine all those with x squared, with x and y on the left side, on the right side first, and those without here. So if with that, I'm going to have a raised to 4 minus a squared c squared is equal to a squared x squared. I'm going to write this beside x squared. That's minus c squared x squared plus a squared y squared. I can factor out a squared here, so I'm going to have a squared multiplied to a squared minus c squared is equal to. I can also factor out x squared here, so I'm going to have a squared minus c squared x squared plus a squared y squared. Since this is most probably a positive number, and we saw a while ago that a is bigger than c, then a squared will be bigger than c squared. So therefore, we can let b squared be equal to a squared minus c squared, which is more or less a positive number. So therefore, replacing a squared minus c squared, that's a squared b squared is equal to, that becomes b squared x squared plus a squared y squared. We now divide both sides by a squared b squared. What we're going to have would be this a squared b squared becomes 1. If we divide this, b squared gets cancelled here, and this is what remains. If we divide this here, a squared gets cancelled, and this is what remains. X squared over a squared plus y squared over b squared. So now we have the equation, the standard form of the equation of the ellipse with center at 0, 0, and it looks like it's horizontal. It's horizontally oriented as x squared over a squared plus y squared over b squared equals 1.